Microwave measurements, power measurements. Series on microwave engineering. Lecture number 6.17. Measuring power at microwave frequencies is quite different from measurement of power at low frequencies. We have wattmeters available to measure power at low frequencies. Those meters, wattmeters, they are not useful for measuring power when the power falls in microwave frequency band. What is the reason? Measurement techniques and the instruments used for measurements at low frequencies, their design as well as functioning, they are based on the concepts of voltages and currents. They can measure the power only when the signal is described with voltages and currents. At microwave frequencies, voltage and current, they are not at all used either to analyze a phenomena or to design a circuit. There, most of the times, it is the power of the signal that matters. Power, sometimes along with field intensity, play a crucial role, a critical role, either in description or in the design of high frequency or microwave devices and circuits. Now one can see very easily why lower frequency techniques, lower frequency instruments become useless at microwave frequencies. To measure microwave power, an instrument is designed, it is available in the laboratories. It is called power meter. It is able to give an indication regarding microwave power. It is basically a bridge circuit. In one of its arms, there exists a temperature sensitive element. When microwave power falls over this element, depending upon the amount of power, temperature changes, changing the resistance of the element, disturbing the balance of the bridge. The amount of unbalance in the bridge depends upon the power that is incident over the element. Sometimes measurements of certain quantities require finding the ratios of powers. Their absolute powers are not required. In such cases, the ratios can be determined by using CRO or a multimeter. Power meter is somewhat costly when compared to a multimeter. Hence, the requirement is ratio of powers. We need not purchase power meter. Multimeter works well. Power meter is essential when the need is to find absolute value of the power. In the present session, the focus is on power meter and its internal bridge circuit. Notice in this session, we are concerned very little with microwave bench. Now let us move further into the core session. Two different methods are widely used in measuring microwave power: bridge methods and calorimetric methods. In bridge methods, a bridge arrangement with 4 resistances as its arms is invariably used. Bridge arrangement is used. That's why these methods are called bridge methods. In one of the arms, a temperature sensitive resistance is placed. The power to be measured is made to fall over this resistance. When no power is falling over the arm, the values of arm resistance are set to give the bridge a balance. In the absence of power, the bridge is balanced. When power falls, naturally, certain amount of unbalance sets in. When microwave power falls over the arm with the temperature sensitive resistance, it absorbs the power of the wave, converts it into heat, rising its temperature. This rise causes a change in the resistance value of the arm, thus disturbing the balance of the bridge. It can be easily observed that amount of imbalance of the bridge is a measure of amount of incident power. By measuring this imbalance using a voltmeter, incident power can be determined. Two types of temperature sensitive resistances are used in the bridge circuit for measurement or measurement. Barometers and thermistors. Together they are called bolometers. Hence, bolometers, there exist two types in bolometers. One type is barometers. Another type is thermistors. In barometers, resistance rises with the temperature, whereas in thermistors, resistance falls with the temperature. A few important points regarding barometers and thermistors. Barometers are thin, short platinum wires used to measure low power levels. Their resistance change at the rate of 5 ohms per milliwatt of incident microwave power. These are very delicate and sensitive devices, highly useful to measure very low power levels, less than few milliwatts. They have positive temperature quotient of resistance. It means temperature increase causes resistance rise. Another type of bolometers, they are thermistors. These are semiconductor devices with negative temperature quotient of resistance. These are widely used to measure low and medium microwave power levels. The change in resistance is 60.5 ohms per milliwatt of incident microwave power. Here are shown two graphs. One graph pertaining to barometers, another graph pertaining to thermistors. A pertains to barometers, B pertains to thermistors. In barometers, resistance is rising with the rise in the incident power. In thermistors, resistance is falling with the rise in power. A few points regarding power meter. Power meter is a bridge circuit, a balanced bridge circuit, in which one of the arms is a bolometer. The microwave power incident over this arm changes its resistance, driving the bridge into unbalance. The amount of unbalance is proportional to incident microwave power. It is amplified using a bridge amplifier and measured using a voltmeter. Deflection in the voltmeter, therefore, is an indication of the incident power over the temperature sensitive arm. The voltmeter then can be calibrated to read the power directly. These single bridge circuits, however, give erroneous readings due to mismatch at the microwave input port and also due to sensitivity of thermistor to ambient temperature. These shortcomings can, however, be overcome by adopting double identical bridge arrangement. Now we move to second category of power measurement methods, calorimetric methods. Calorimetric methods are useful to measure high microwave powers. These methods involve conversion of microwave energy into heat, absorption of heat by some liquid or dielectric, rising its temperature, and then measurement of this rise in temperature of the liquid or dielectric. The rise in temperature can be seen depending upon energy of the incident wave or power of the incident wave. So rise in temperature gives an indication regarding the power in the incident wave. Two types of calorimetric methods are in use, which are described right now. One is static calorimeter. One method uses static calorimeter. It consists of a 50 ohm coaxial cable filled with a dielectric load with a high hysteresis loss. The wave is made to pass through the cable for a certain amount of time and allowed to get dissipated there. The resultant rise in temperature is measured to find the input power. The average input is input power. Average input power P is 4.18 mCp T by T, where T is time in seconds. This is time. Capital T is temperature in degrees C. The M is mass of the medium in grams. Cp is specific heat. Understanding this particular relation is not that much difficult. Now we move to another calorimetric method, that is circulating calorimeter method. So this is the microwave power which we want to measure. It is supplied to a microwave load. So load generates heat. Some fluid is flown over the load. Naturally, when the fluid comes in contact with the load, certain amount of heat enters into the fluid, rising its temperature. Temperature before crossing the load, temperature after crossing the load. These two temperatures are measured. The difference between these two provides information pertaining to microwave power. In this method, the power is made to fall on the water flowing at a constant rate through a water load. The heat introduced into the fluid makes the exit temperature to be higher than the input temperature. The incident power P is then measured using the relation P equal to 4.18 VdCp T watts, where V is the rate of the flow of the fluid in cc per second, D is specific gravity of the fluid in grams per second, Cp is specific heat in calories per gram. Notice in calorimetric methods and also in bridge methods, microwave power is being converted into heat first. It is not being measured as it is. The heat is then made to change resistance in bridge methods, and here in calorimetric methods, the temperature. By measuring the difference between resistances, between temperatures, the incident power is being estimated. These are some of the points which I want to share with you for right now. Hope you have enjoyed this session. Enough for now. See you again in another session soon.